Now, this is where the rubber meets the road for your AI first company. You can implement data into an existing large language model in these red areas. Now, let's talk about the first one. We've got this deep neural network that understands how to write sentences. It understands chocolate chip cookie recipes. It understands how to write poems, book reports, cats. It understands all this general information. But it doesn't understand you. And it definitely does not understand your internal data. Now, let me digress again since we're in part two. ChatGPT 5 is crawling the internet. Today, it is crawling the internet. You know Dubai is crawling the internet. You know Llama 3 is crawling the internet. You know Bard and Google are working on an update. Claude is going to come out with Claude 3. Make sure all the data in your organization is good quality data. Right? This is very important. Don't leave any old data out on your public internet sites. And in fact, you want to tune your public internet site to have better data when these large language models come along and it's your turn to be scraped. Now, why would you want to do that? Because a lot of companies are putting up this little robot text file that says, you may not come into my company. You may, Yelp doesn't want, OpenAI reading all their reviews. Amazon doesn't want them reading all their product descriptions, et cetera, et cetera. But you want it to read you. Right? You're out there marketing your company, you're doing sales calls, et cetera, et cetera. So someone is going to come into Llama 3, a potential customer is going to come into Llama 3 one day, and they're going to go, tell me about company XYZ. Oh, well, company XYZ is boring, and they don't do anything, and this data is wrong, and it's hallucinating, da 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 da. Oh, okay, hold on. Tell me about a different company. Oh, that's the company I want to hire. So again, this is a digression, but it is of critical importance that your data be outstanding out on the internet. Don't leave anything out of date out there because these large language models get to every bit of it. And in fact, a lot of people think that's where hallucinations come from. It's just junk sitting out on the internet that someone should have turned off or deleted from the website. Okay, digression over. So I have a lot of very general information about my company, right? Okay, you know some stuff that was out in the public on the internet, but you don't know all my intranet stuff. You don't know my knowledge base. You don't know my databases. I got a ton of information that's sitting inside my company that I want to be able to use with this large language model. Well, you're going to do that by just adding it onto the end of the data stack. So whatever data that Meta Llama 2 has, you're just going to bolt your data right into it. So if this is stored in a vector, okay, what's a vector? Okay, I need to store in a vector. So I'm going to take my data and I'm going to store it in a vector too. Now what I'm going to do is I'm going to tell this neural network, look, I'm going to give you some limitations. First of all, no chocolate chip cookie recipes, no writing poems, no helping kids with their cat book reports on my dime, right? This is expensive and I don't want them coming in and just asking general questions. So I'm not only going to add my data, vectorize my data and add it on top of Llama 2, but I'm going to tell my prompt, you can only ask questions about this red box. Now that is really, really cool because when it comes through and gets that question, I'm interested in XYZ. Can you tell me more? I don't know. I'm sorry, that does not compute. My company doesn't do that. But if it asks you a question about your company, then it's going to say, sure, I've got the answer right here in this red box that was added on top of the already existing data. This is where you add all your general information. So anything you need to know about the company, and remember, you're employee first right now. You're AI first, of course, but you're empowering your employees. So again, this is where you create that oracle. You take every single thing in your organization and you plop it right into an LLM, or you stack it on top of it. Okay, that's the first piece. The second piece is that you actually come in and you trim off some of these 96 hidden layers. Now this is very powerful, but it's much more expensive because right now you're saying, look, the neural network was just trained in general, right? It's not a specialist in anything. It's certainly not a specialist in my company. So what I'm going to do is I'm going to come along and I'm going to cut off layer numbers 96, 95, 94, 93, and then I'm going to stop it right there at 92, and I'm only going to put my data into the end of that network. So now, remember, we talked about bad model. You got an F, go back, change it. You got a bad, change it. Change the weights, change the way the neurons vibrate. Now you can actually be part of the neuron training and the neuron weighting and tuning without having to build this thing from scratch. You're only snipping off the last few layers. This is very expensive. Be ready to spend tens of thousands of dollars in order to do transfer learning. So you probably want to start with just embedding your own data on top. Now, this brings us to a third piece, which is kind of new and it's quite interesting. And that's this upfront piece. Now, this is where you hear about, can I chat with my PDF? Can I chat with my own data? Can I upload a book and then ask my book questions? Can I take all my notes? Google now allows me to take all my notes in my university classes and store them somewhere. And then I can ask my personal notes from class anything I want. Well, this is put in up front and it's put in as we go. So this is embedded. Right? Everything you'd ever want to know about my company. Again, make sure it's current data so it doesn't hallucinate. I'm not going to do transfer learning because that's just going to cost way too much right now. And we're just getting into this. But this upfront part is called, well, I don't even want to tell you what it's called because it's a very technical term. But basically what I'm going to do is I'm going to add some data based on the question I'm about to ask. Now let's look at an example. Let's say we have a call center. All right, so let's say we own a call center and Mary is dialing into the call center. Press 1 for customer service. Press 2 if you have this issue. Press 3 if you have this issue. So while Mary is in that queue getting ready to speak to a call service representative, what we're doing behind the scenes is we say, here comes Mary. So go to the company's internal databases and I want you to query everything we know about Mary. Let me say that again. We want you to go retrieve into one document every single thing we know about Mary because Mary is in queue and I'm about to have to talk to Mary. So Mary's records, all her records are transferred right from the database into this red document in preparation for Mary. Now, here's what I would suggest we do. You convert it to questions and answers. Now, the neural network can just take web pages. It can take anything, right? It's like, whatever, embed whatever you want to do, transfer, learn, whatever you do, yada, yada, yada. Give me anything. Give me a PDF on the notes you took at university, and I'll try to figure it out from there. However, remember, a large language model starts with a question, ends with an answer. Starts with a question, ends with an answer. So if we can convert all of Mary's data into narratives, what is Mary's bank account balance? Well, Mary's bank account balance is X. Well, when is Mary's loan next due for her car? Mary doesn't have a car loan. Whatever it is, we end up generating a 300-page document on Mary that takes her numerical data and puts it into Q&A. Now, this is mind-blowing. Right? This is absolutely mind-blowing. We're really faking out this neural network and we're doing it on terms that the neural network loves. Prompt answer, prompt answer, prompt answer, prompt answer. That's my bread and butter. That's how I make a living. So what happens is, hi Mary, how can I help you today? Boom. All of a sudden that 300 pages of Mary data is loaded directly into the AI. Oh, well, I'm interested in what my bank account balance is. And so the call server said, what is Mary's bank account balance? Oh, Mary's bank account balance is XYZ. So all the call center person has to do is ask the questions, and the call center person is blown away. I can't get over how much this large language model or this AI knows about Mary. Well, it's because we just loaded Mary. Right? Just literally 1 second ago, we popped Mary in front of this AI and said only answer questions specific to Mary and to the overall company in general, in case, she's asking a question, the Mary is asking a question in general. Now, what ends up happening is this is very temporary because as a company, your regulatory officer, compliance officer, and general counsel are saying, I told you we shouldn't be using AI. I don't care about this Llama 2. I don't care about copying it over to Amazon. This is a no-go because do you know how much personal, private information and numbers are sitting inside that database? Well, chill, because we're only going to use it while Mary's on the phone with us. So in a way, this is temporarily created, temporarily bolted onto the front. It never touches Llama 2. It never touches your embeddings. It ain't touching anything. It is never stored. Just think about it sitting in ether while Mary's on the phone. Thank you so much, Mary. If you'll stay on the phone, you can grade customer service, yada, 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 and poof. all of Mary's 300 pages is gone. It evaporates. Even if Mary calls back in an hour and says, I'm so sorry, I forgot a question, we're going to go through this all over again. Because you know what? Mary may have gone to buy a cup of coffee, and so her bank balance is going to change. That is, look, this is where you win. I'm going to tell you right now, yes, you want to embed, definitely embed. But what you want to do is you want to feed it highly tuned, very temporary specific data into the front of the LLM so your customer service reps are not having to read a bunch of screens and go from page to page and look in tables. All it is a conversation. Now, again, this is only empowering employees. You get it? Only empowering our employees. Mary still has to call into the call center for now. But again, can you imagine once this goes into the public? Mary comes in and says, hey, I'd like to ask some questions about my bank account. Mary, please hold. Okay, and it's ready. Right? Ask me anything you want, Mary. I'm ready to go. Okay, so I know this is getting to be a very long video, but this part 4 is very, very important. Basically, let's talk, this is near and dear to my heart, right? This is a very technical, but I'll keep it simple. No model can fit on one GPU. So now you kind of understand why these GPUs are so expensive. An A100 may retail for 15 grand. It may sell for $40,000. And it's got 40 gigs of RAM on there. It's got 80 gigs of RAM. It's got a certain amount of memory, and Llama is laughing at it. Llama is going, patooey. There's no way I'm going to be able to fit on you. So you're going to need 4 or 5 of these $40,000 GPUs in order for me to fit on you, right? Then the second piece is that you can also do data across different GPUs. So if I'm training this neural network, I can say, well, come on, take the 8s and send it to this GPU, take the 7s and send it to this GPU, and then, kind of talk to one another. Hey, how you doing? I'm not doing very good. I'm getting an F. Oh, how are you doing? I'm getting a D. Okay, let's go ahead and work together to tune. Okay, give the 7 this GPU, the 4 this GPU, etc. You can actually break a single model across GPUs. So you can run one model and spread it across these GPUs. Remember, going back to the library, remember those tens of thousands of GPUs that are all linked together? This is how it works. And then finally, and this is something I'm working on right now, is that you can take a single neuron in this artificial network, and you can put it on a GPU. So you can actually do different parts of neurons sitting on different GPUs. And again, this is all to speed up the process.